Introducing the unboxing and usage tutorial of STR400. Fisher, let me show you what's in the STR400 package. Number 1. Factory Inspection Certificate of Robotic Arm. Number 2. USB to RS485 serial converter cable. It is used to connect the robotic arm and the host computer. Number 3. Power adapter for robotic arm. It is 24 volts 5A. And number 4 is the body of the robotic arm. The base of the robotic arm is a 75 mm hole spacing with M6 bolt. It is a through hole, so this arm can be locked onto any standard optical table. Now let's see the base. This is the power interface, and this is the communication interface. Okay, now let's lock the arm on the table. This is a standard optical table board. We use M6 screws to lock it. It is worth mentioning that the base of the robotic arm must be locked on a very stable and solid platform. Otherwise, there will be risks during the movement of the robotic arm. We must tighten these 4 screws firmly. First, connect this communication interface. And connect the power interface. Connect the USB end of the serial converter cable to the computer. Connect the power and turn on the switch. When the robotic arm is powered on, the green light on the base will light up. Okay, now let's open the software. Copy the user interface link. It is worth mentioning that this terminal will display various movement information of the robotic arm, includes error data and current status of the robotic arm. Now we open this link in the browser. This is the home page of the robotic arm software. Here we select the baud rate and serial number and click Connect. Now we have entered the menu of the robotic arm. The center is the effect of a digital twin. It maps the motion state of our robotic arm in the physical world. Let's try dragging it now. Now I explain the interface to you from left to right. The column on the left, V0.2.66, is our current software version number. Here we can switch the language. Then the following one is dashboard. It shows the status of our joint. The red color indicates that it is not started. It means that the joint is in the state of disable, and it can be dragged now. The column on the right shows normal. It means that the joint temperature and the load is normal. The block on the right shows the angle from the first axis to the 6th axis of the arm, and the Cartesian coordinates of each joint. Here is a quick operation menu in the lower right corner, the active mode. It means the robotic arm is powered on. And there is a disconnect the serial port. Now we return to the left, the teaching mode and W script. These 2 functions will be demonstrated later. Here is parameter setting. Here we can set the port of the link and the length of the end actuator. For example, you need to install a gripper on the end or other tool. We can set its length here. This parameter determines the forward and inverse solution algorithms of the robotic arm. This is the robotic arm settings. It can set preset position 1 and preset position 2. We can set the angle of each joint. The current default position is the first axis is 0 degrees, the second axis is 0 degrees, third axis 90 degrees, and 0 degrees, 90 degrees, 0 degrees. Then is the default position 2. Each joint is 0 degrees. We can also customize the position. Now let's try to make the arm move. The first step is to click on active mode and click Start. The robotic arm is now enabled. Each joint is braked. It is locked. Now we click on the joint to return to 0. Wait for it to return to home position. Okay, we try to click the position 1. And click the position 2. Return to the position 1. In this braking mode, we can make it emergency brake during the movement of the robot arm. Let's try it. Okay, the arm emergency brake. Now click the position 1 again. Then this passive mode. It disables each joint. It means we can automatically drag the robotic arm. Let's try it. Now let's click on active mode again. The robotic arm returns to the braking state. We go to the position 1. Why do we need to return to default position 1 first? Because this position is its best working posture. So when we perform any operation, it is best to start with this attitude. Okay, now let's take a look at the real-time control. Real-time control can control the Cartesian coordinates of the end in real time. Let's try it. Now we press X. X. X plus. Y. Y plus. Okay, we click to stop the task. Return to the position 1. Now we demonstrate the perspective mode. We click Create Trajectory. This is a new trajectory action we created. And we click Edit. We can also add a trajectory for the current posture. In teaching mode, we have 3 modes. The first mode is Move J. Move J is the simplest control. We can make 6 joints reach the specified angle at the same time. The second mode is Move L. It means that the end of the robotic arm performs in a straight line. The third one is Move S. It is a powerful and special algorithm for trajectory planning. When we set more than 3 positions, it can draw a very smooth curve through these points. That is, Move S enables a variety of smooth and complex movements. Let's try to create a Move J first. And the move time. We now use real-time control to move the arm. Now we want to move from the previous position to the current position in a straight line. So we create a Move L. Then move the robotic arm upwards and create a Move L. Move to the right. Create the next Move L. And move down. Then Move L. Okay, let's run it. Click OK and stop the task. And start to run the trajectory. Okay, now it's done. Here is a loop pattern. We have no restrictions here. So theoretically we can input infinitely large data. We can make this robotic arm run repeatedly along this trajectory. Okay, we stop the task. And return to the position 1. Next we demonstrate Move S. Similarly, we first add a move J. We turn this robotic arm in passive mode. Okay, this is the first position. And the second point. The third position. The fourth. The fifth. The sixth. And the seventh. Now we try to run it. We can see that in MoveS, all positions form a silky trajectory. And the whole process is very coherent and silky smooth. Finally, let's try W script. It means we can program move J, move L, move S. Let's try it. About how to write W script, you can go to our GitHub. There we show some sample code. Now we run the demo script. Okay, now all the functions have been demonstrated. There is also mobile phone control. We can connect our mobile phones and computers to the same Wi-Fi and access this user interface by scanning the QR code. This way we can control the robotic arm through a phone or pad. There are more gameplay codes and sample SDK. We will update them simultaneously on our website. That's all. Thank you for watching.